Hey guys. All right, so we got to figure out how to make this big. There we go. Okay. We are doing ratios and proportions today, starting Unit 7 of Similarity. So a ratio is a comparison of two quantities by division. So it's going to look like a fraction the majority of the time, but ratios can also be written as A to B, so you can write a 2 in between the two topics, or you can put a colon there, A colon B, or of course we can write it as the fraction. Now, all of this is due as long as, I'm not sure what that is, but it's supposed to say B does not equal 0. So as long as we do not have a 0 in the denominator, we are good. All right, examples of ratios. You guys have ratios all over the place in your world. First one here looks like Nicholas ate 2/3 of a pizza. So you guys can talk about if you eat 2/3 of a pizza, or if you eat 4 pieces out of 8 pieces, that would be 1/2 of a pizza. The biggest one you guys are going to start looking at is gas is $2.59 per gallon. Well, right now with all this quarantine stuff, gas is actually like $1.70 something, I feel like, per gallon, which is super cheap, which is really good for you guys. But you're going to have to start paying attention to those different ratios, like miles per hour on the highway and all that kind of stuff. All right, in our class, we are going to write ratios in the same unit of measurement. So whenever we have a basic ratio like this first one, a scale model of a car is 4 inches long. The actual car is 5 feet long. What is the ratio of the length of the model to the length of the car? So it tells you what order to write your ratio in. It says length of the model to length of the car. So I'm going to write a word fraction over here. So we're doing model to the actual car. So whenever you set up your ratio, this is what we want to look at. Model to actual car. So the length of the model, it says it was 4 inches. And then the length of the actual car is 15 feet. Now, whenever we're in a ratio, we want to make these the same unit. So how would we make 4 inches and 15 feet the same unit? Hopefully you know that you should multiply the feet by 12 to get you into inches. So that would give us 4 inches over 15 times 12, which would give us 180 inches. And then, of course, we need to reduce. So then we would be doing 4 divided by 180. And then you hit math, enter to make it a fraction. So that would be 1 over 45 inches. So what's the ratio of the length of the model to the length of the car? How we would think of that would be for every 1 inch of the model, that equals 45 inches of the actual car. So that would be our answer. All right, a proportion is a statement that two ratios are equal. So we're going to put two of these fractions equal to each other. So a proportion can be written in the form of two fractions equal, A to B equals C to D, and it could also be written as your colon statements, so A to B equals C to D in one horizontal line. In this class, proportions can be written with different unit measurements. So we don't have to have the same unit measurements all the time in proportions. We can write them with different. Two equations are equivalent when either can be deduced from the other using a property of equality. Several equations are equivalent to a proportion. So proportions of our properties of proportion. So if we have a basic proportion here, based on properties of proportions, the equivalencies, we can write this proportion in 4 different equivalent ways. So the first one would be multiplying across. So if we took our ratio and we cross multiplied, that would give us option 1. AD equals BC. Option 2, it's also equivalent if we take our first one and we flip it upside down. So A to B equals C to D would be the same as saying B to A equals D to C. So you're just flipping your fractions upside down. Okay, the third equivalency here, A to C equals B to D. So we can go across the top. So we can flip here. So A and C can go in the same fraction or ratio, and that can equal B to D in the same ratio. And then our fourth equivalency here is a sum over a fraction. So if you do A to B, so if you do A plus B and divide it by B, then that would be equal to C plus D divided by D. This one is probably one of the least common ones we use, but it may show up and you may forget about it. So I would try to still remember it, even though it doesn't show up as often. All right, with that being said, we need to complete the following statements. So if A over 4 equals 12 over B, then B over 12 equals what? So which one of these equivalencies up at the top did we use? Well, it looks like we put B over 12. So it looks like we flipped the fractions upside down. So which one did we flip fractions upside down with? That would be option 2 here on equivalency. So then we would flip the other fraction upside down. So you would put 4 over A. B, if x over y equals 4 over 5, then 5x equals what? So what did we do to get 5x? Looks like we cross multiplied. So that was our property 1 here of proportions. So then we would need to cross multiply the other way to give us 4y. And C, if C over 7 equals D over 9, then C over D equals what? So it looks like we did C over D, which are the top, the numerator of our fractions. So that is option 3 here. So that means our other fraction, if we went C to D, we would need to go 7 to 9 for our other ratio. Don't forget you can pause this video at any time and rewind if I'm going too fast for you. Solve each proportion. So whenever we're solving proportions, we cross multiply. So I'm going to cross here and multiply. So 5n equals, and then I'm going to cross here and multiply. So that gives me 70. So then we take 70 and divide it by 5, and we get n equals 14 for our answer. B. This one looks a little tricky because it's in the colon type of proportion. So you have two options here. You can either cross multiply while it's in this, or you can put them into fractions if that makes it easier for you. So if we were to cross multiply while we are in the colon form, that would be outside first. So 16x equals inside second. So 36 times 24 is 864. And then divide that by 16. So x equals 54. Now, if you wanted to, you could have come over here and put them into fractions. So 16 over 36 equals 24 over x, and then you could have cross multiplied, giving you the same next step of work that you see whenever we go outside and inside of the colon. All right, this one, you can see that we have more than just one thing in the numerator over here. So what that means, whenever we cross here, we have to do 2 times the quantity of x plus 1. So in other words, we're going to have to distribute that 2 to everything in that numerator. And then you cross the other way and you get 3x. So that would give us 2x plus 2 equals 3x. And then we would subtract the 2x, so x would equal 2 in this case. Oh, looks like that's the last problem there. All right, when 3 or more ratios are equal, extended proportions can be written. So solve each proportion if it's an extended proportion. So basically what we're talking about is if we've got more than one ratio set equal to each other, all of them, each one of the ratios has to reduce to the same thing. So 24 over 48 is equal to 1/2. It reduces to 1/2. 5 over 10 also reduces to 1/2. So this extended proportion, all pieces of the ratios are going to simplify to 1/2, making it equivalent. So let's try it. If we look at 8 over 12, that reduces down to 2/3. So then what we have to do is, what I like to do is just take them and do them separately. So 2/3 has to be equivalent to 6 over x, and 2/3 has to also be equivalent to 12 over y. So we have to have, I basically set up two different proportions to solve for each variable. So then we cross multiply here, giving us 2x equals 18, so x equals 9. And then we cross multiply to solve for y, giving us 2y equals, 36? So y equals 18. So now we've solved for those. If you would like to check your work on that, what you can do is, let me zoom out a little bit here. So 8 over 12 was equal to 2 over 3. So 6 over x, 6 over 9, and then 12 over 18. So all three of those have to equal 2/3. So 6 over 9, if we divide both things by 3, that would give us a 2/3. And also 12 over 18, if we divide those by 6, that would give us a 2/3. So all of them end up equaling the same ratio, which means we solved the problem correctly. All right, B. Okay, so what we're looking at here now is we've got an x, an x, an x, and a y, but we don't have a full ratio to go off of, which is okay. So we are going to split it. I'm going to take the first proportion here, the x's equal to each other, and I'm going to solve this because I don't want to involve the y yet whenever I don't know what x equals. So I'm just going to focus on these two and cross multiply. So that gives me 18x equals, don't forget we have to distribute the 6. So that's 6x plus 60. And then subtract your 6. So that gives us 12x equals 60. Divide by 12. So x should equal 5. Now that you have x equals 5, what you can do, let me get a different color here, is I'm going to take this basic proportion and I'm going to take the last ratio. So x over 6, we just found that to be 5. So we're going to do 5 over 6 equals 4 times x, so I'm going to plug in a 5 there, over y. So now we've got rid of our x's. We have a basic ratio of 5 over 6 that this last ratio has to be equivalent to. So we're going to solve it this way. So that would give us 5y equals, this is 20. So 20 times 6 would give us 120. Divide that by 5. So y equals 24. Okay, so we've solved all those extended proportions. Once again, if you have any questions, email your teacher or pause, rewind, rewatch until you understand it. All right, in a scale drawing, the scale compares each length in the drawing to an actual length. The lengths used in a scale can be different units, like we talked about before. Proportions can be used to find the actual dimensions represented in the scale. So we're basically going on to word problems now. Two cities are 3.5 inches apart on a map that has a scale of 1 inch equals 50 miles. So this is kind of like a history problem as well. Hopefully you guys have maybe done some scale stuff in history in the past, or you've done it this year, not sure quite yet. But find the actual distance between the two cities. So basically what we're looking at is we've got 1 inch to 50 miles. And we know on the map, the two cities are 3.5 inches apart. So please note that I put the inches on the top of our fractions in the numerator. So you have to stay consistent on where you put the common measurements. So then we don't know how far the two cities are actually apart. So I'm going to put an X there. And then I'm going to solve the problem. So we cross multiply. So that would give us 1x equals, and whenever you multiply 50 by 3.5, that would give us 175. Now, you may be wondering, well, what units do I put? X is in the denominator of the fraction, so that means it's on the miles portion of the ratio. So our answer would be, therefore, it's a word problem, the actual distance between the two cities is 175 miles. Period. Don't forget your label on your answer. All right. Next example. A painting is 24 inches wide by 36 inches long. So we're going inches by inches, which that's kind of nice. So we're looking at width versus length here. So 24 by 36. If you want to put over to the side, the width is on top and the length is on bottom of the fraction. So then the length of the postcard reduction means a decrease in size. So we took the painting, we reduced it, so we shrunk it to be on a little postcard. So the length of the postcard reduction of the painting is 6 inches. So that was the length. So length was on the bottom. So I'm going to put the 6 on the denominator of the ratio. It says how wide is the postcard. Wide was on the numerator. So I'm going to put my X in the numerator. And then we cross multiply and solve. So we're at 36x equals 24 times 6. It's 144. Divide that by 36. So x equals 4 inches. So therefore, how wide is the postcard? The postcard is 4 inches wide. Period. All right. Hopefully you're doing pretty good still. Okay, let's flip the page. We are on the last page. Yay. All right, so we are talking here just using basic proportions to solve really any type of problem that compares two different things. So we're going to look at this, and it says about 45 of every 300 apples picked at Newberry Apple Orchard are rotted. So hopefully you know the important pieces in here. 45 of 300 apples, and then I'm going to underline rotted because these apples are rotted. If 3,560 apples were picked one week, how many of those are rotted? Oh, we forgot to underline the good word picked up here. Okay, so it looks like we've got rotted, and then we're talking about how many you actually picked. So out of all the apples you picked, how many of them are rotted? So in the first batch here, 45 are going to be rotted out of every 300 apples that you pick. I don't know if that's a good ratio or not. I don't know much about orchards, and I'm going to assume that's probably pretty good, but maybe Newberry apple has not so great. I don't know. You can Google it. Okay, so 45 out of every 300 apples picked are rotted. If 3,560 apples were picked, so that's going to go on my denominator, how many were rotted that week? So I'm going to put X on the top in the rotted spot. Cross multiply. So we've got 300x equals, yes, some of these numbers can get very big. 45 times 3560. Oh boy. So that's 160200. Divide that by 300. I get 534. So, about how many were rotted? Therefore, there were 534 rotted apples that week. Period. I don't know. I feel like that's an okay amount of rotted apples. I feel like kind of calling an orchard to see how realistic this is. I'm assuming we've got it from a good source, right? Yeah, we're going to assume so. Okay, next problem. A grocer orders 600 gallons of 600. Where did I get that number? 800 gallons of milk each week. He throws out 64 gallons of spoiled milk. Ugh. That's gross. All right. So it looks like we're doing kind of the same thing, but with milk this time. So we're talking spoiled milk over ordered milk. So we've got 64 gallons that are spoiled out of every 800 gallons that we ordered. So of 9,600 gallons of milk ordered, so that's going to go on bottom, we want to know how many gallons are spoiled. So X is on top. All right, cross multiply. Oh, this is going to be an even bigger number. 800x equals 64 times 9600 is 614400. Hoping I'm right. I'm using a calculator right here. I hope you guys know I cannot do this stuff in my head. Divided by, whoops, I almost put 900. Divided by 800, I got 768. 768. Hopefully you guys got the same thing. If not, Google Hangouts me. Is that even that's a sentence today. All right, so therefore, about how many gallons of spoiled milk were thrown away? About 768 gallons of, what was that? Of spoiled milk were thrown away. And period. All right. Hope you guys are doing good at this. I think it's pretty easy. I hope you find it pretty easy too. I don't know. If not, I'm sure I'll hear from you, because I know you guys love telling me your opinion. Okay, I'm changing up colors for the last problem. A principal who is 68 inches tall, so we're going to circle that. 68, that was a bad circle. 68 inches tall, measures shadows to find the height of a school. The principal's shadow is 24 inches long. So that's his shadow. And he's 68 inches tall. In the shadow of the school, so shadow of the school is 20 feet. I would pay attention to that. We just switched units. Draw a picture to illustrate the question, then write and solve a proportion to find the height of the school in inches. So we've got to do 3 things here. We need to draw, we need to write, and we need to solve a proportion. And then it is bolded over here. You need your final answer in inches. Okay, so let's get to drawing. We're going to have a blue little principal over here. So we've got a blue little principal. It said, what do you say? He was 68 inches tall. And his little shadow down here is 20. That's kind of a big shadow. Little shadow is 24 inches. And then we've got a school. So we'll draw this big old school. Door, windows. Yeah, that looks good. And it says its shadow is 20 feet. So its little shadow out here is 20 feet. I'm going to label this inches over here. And then we want to know X. We want to know the height. So there's my picture. Check. Let me pick a different color. What color do you guys want? Oh, can't hear you. Haha, I'm picking purple. All right, so we drew a picture. Now we need to write and solve a proportion. Well, Ms. Vogler, how am I going to do this? We're going to get more into this in the next couple lessons, but if you can't see it or you're not that common sense oriented, we have right triangles in here. Yes, I know. Some of you are like, oh my gosh, she is not bringing back right triangles. Guess what, guys? I'm bringing back right triangles. They never go away. So we've got right triangles in here. Just an FYI, pay attention to that because it will come up soon. But we need to write and solve a proportion. So we've got the height. Let's do the height. So 68 over X. So we've got the height, and then we've got the shadows. So 24 over 20. Now, if you wanted to, you could do height over shadow. So 28 or 68 over 24 and height over shadow of the building. Either one of these proportions is 100% correct. Okay, either one. Now, I'm going to go with the first one that I picked. So I'm going to delete this one. There's an issue here though. So I want my final answer in inches. I boxed that in. But one of these numbers in here is not in inches. So what you need to recognize is this 20 is in feet. So we need to multiply that by 12. So 20 times 12 gives us 240. 240 inches. So I am going to erase this 20 and I'm going to put 240 instead. Therefore, I will have inches as my final answer. Now we solve it like normal. Cross multiply. So 24x equals 240 times 68. Another big number, 16320. And then divide that by 24. So we get 680. And that's in inches. So the problem said, draw a picture to illustrate the question. We drew the picture. Write a proportion. We wrote the proportion. We solved the proportion to find the height of the school in inches. So now we just need our therefore sentence. So therefore, the school is 680 inches tall. Or if you want to write something like the height of the school is 680 inches, that would be fine. Okay. All right. I hope these notes were not difficult for you. I hope you understood them. And if you have any questions or need to go back and replay anything, feel free to do that. Feel free to email me. Feel free to Google Hangout me, whatever it's called. Yeah. All right. We'll talk to you guys later.